I will be presenting on Zener diode voltage regulations. Electronic devices require a stable DC voltage to operate properly. However, the input voltage can fluctuate due to battery discharge or ripple from rectified AC supplies. Without regulation, these changes can affect circuit performance or even damage sensitive components. A Zener voltage regulator solves this problem by maintaining a constant output voltage despite changes in the input voltage or load current. In this presentation, I will explain the Zener breakdown principle, describe how the regulator circuit works, perform basic circuit calculations, and discuss its applications, advantages, and limitations. Theoretical background, the Zener effect. To understand voltage regulation, we first need to understand the Zener effect. Unlike an ordinary diode, which may become permanently damaged when reverse breakdown occurs, a Zener diode is specifically designed to operate safely in the reverse background region. When the reverse voltage reaches its rated value, known as the Zener voltage or Vz, the diode enters breakdown. At this point, although the current through the diode can continue to increase, the voltage across the diode remains almost constant. This unique characteristic makes the Zener diode an excellent voltage regulator because it can maintain a stable output voltage even when the input voltage or the load current varies. Looking at the graph on the right side, we can observe the voltage current or VI characteristic of the Zener diode. In forward bias, it behaves like a normal silicon diode. However, in reverse bias, once the voltage reaches Vz, the current increases sharply while the voltage remains nearly constant. This constant voltage region is exactly what allows the Zener diode to act as a reliable voltage reference in many electronic circuits. Therefore, the Zener diode effect forms the fundamental operating principle of every Zener voltage regulator.
Okay, the next part I will explain about circuit operation. Based on figure 2, basic Zener diode voltage regulator circuit. How it works? RS limit current flowing from the unregulated supply Vin into the circuit. The Zener diode DZ is reverse biased and connected in parallel with the load RL. The output voltage is taken directly across the diode, so Vout is equal to Vz. Because the load sits in parallel with DZ, Vout stays fixed at Vz even if Vin or RL change.
Analysis and result. Relevant equation and sample analysis. The balance at Iz equal to Is minus IL explains that the total current entering the circuit Is is split into two parts. Same goes to power the device IL and the rest is swallowed by the Zener Iz. The work example. First, the circuit pulls a total of 7 mA from the 12-volt power supply. Second, the load resistor takes 5 mA of the current to operate at 5 volt. The last, the Zener diode safely absorbs the remaining 2 mA. Emphasize that because the Zener has 2 mA flowing through it, it has enough current to stay on and keep the output perfectly regulated at 5 volt. Next, we move to the non-ideal output. A particle Zener has internal impedance Z, so Vout equal to Vz plus Iz multiply Z, where output shifts load current changes. Second, we have a best operating region. Operating beyond the knee of the VI curve gives more stable impedance and tighter regulation. And last, we have a failure condition, which is if Iz falls below its minimum rated value, the diode leaves breakdown and regulation is lost, where Vout starts following Vin again.
Next, we have advantage and limitation. For advantage, the first one we have simple and inexpensive. Only a Zener diode and one resistor are needed. Second one, easy to design and build with well understood standard equation. third one is provide a stable, predictable reference voltage for low power circuit. Next, for limitation, we have three also. The first one can introduce electrical noise on the DC output. Sometimes needed a decoupling capacitor for smoothing. Second, poor efficiency at higher current. RS dissipate power continuously even under no load condition. The last one is limited to low power application, not suited for high current regulation.
So next is the real world applications. So first we have the DC power supply, which is its rectified DC still contains voltage ripple. Zener diode is connected after the rectifier claims the output voltage to a constant value, reduce ripple and stabilize the DC output, provide a smoother power supplies for electronic circuit. Second is the voltage reference source. It produces a stable reference voltage used in comparator, analog to digital converters, instrumentation amplifier, low cost and reliable. Last but not least is it ensure accurate circuit measurement. The third one is voltage, over voltage and surge protection. It protects sensitive electronic components, clamp excessive voltage to a safe level, divert excess current to ground, commonly used in automotive and industrial electronics. So next is the SCR triggering circuit. Set a precise triggering voltage, control the firing angle of the SCR, improve power control efficiency, used in AC power control applications. And last but not least is the battery powered or embedded system, which it is suitable for a portable electronic devices, consume very little current, maintains a stable reference voltage, help sensor and microcontroller operate reliably, extend battery life by reducing power consumption. So this is the simulation on how Zener diode function in DC power supply. And here is the simulation sample for a voltage reference source. And here is the simulation sample for, and this is the third one of the simulation sample for overvoltage or surge protection. And this is the third one, and this is the simulation sample for a SCR triggering circuit. And the last simulation for today is the battery powered or embedded system. And the last simulation for today is the battery powered or embedded system. And the last simulation for today is the battery powered or embedded system. And the last simulation for today is the battery powered or embedded system. And the last simulation for today is the battery powered or embedded system. And so in conclusion, the Zener diode may be a small electronic component, but it plays a big role in keeping voltage stable and protecting electronic circuit. It is widely used in applications such as DC power supply, voltage reference circuit, overvoltage protection, SCR triggering, and battery-powered devices. Although it has some limitations like lower efficiency and electronic noise, its simplicity, low cost, and reliability make it a practical choice for many electronic systems. Overall, the Zener diode is an important component that helps electronic devices operate safely and efficiently. That's all from us. Thank you.